Hello students, this is Varun. In this video, we will discuss about the solution of quadratic equations. Generally, we have three ways to find solution of quadratic equations. The first one is factorization method, second one completing the square method, and the third one is by using quadratic formula. First, we will discuss factorization method of solution of quadratic equations. Let us consider we have an equation ax square plus bx plus c equals to 0. This is the general form of quadratic equation in which a, b and c are real numbers and a is not equal to 0. If we want to find solution of this equation by using factorization method, for that, first of all, we have to express the quadratic polynomial of left hand side as a product of two linear polynomials. Means we have to factorize this polynomial and we have to write this polynomial as a product of two linear polynomials. Let us suppose that if we factorize ax square plus bx plus c and we are able to write this as a product of two linear polynomials like px plus s into qx plus r equals to 0 as it is. Since product of these two linear expressions is 0 and we know that product of two expressions can be 0 if and only if one of them is 0. It means if product of these two linear expressions is 0, then either px plus s equals to 0 or qx plus r is equals to 0. If px plus s equals to 0, in that case the value of ps will be minus s and the value of x will become minus s upon p. In the same way, qx equals to minus r and the value of x will become minus r upon q. So here we get the value of x as either minus s upon p or minus r upon q. These two values of x are solutions of quadratic equation, or sometimes we use the word roots of quadratic equation. Now let us do some examples for more clarification. Let the question is solve the following quadratic equation by using factorization, and the equation is x square minus 7x minus 60 equals to 0. To solve this equation by using factorization, first of all we have to factorize the polynomial on left hand side, and we know that we can factorize this polynomial by middle term substitution. And for middle term substitution, I want to discuss the algorithm that we have to use. First of all, we have to factorize the constant term of given quadratic equation, and here the constant term is 60. So we have to find factors of 60. Then after we have to express the coefficients of middle term, and the coefficient of middle term is minus 7. We have to express the coefficient of middle term as the sum or difference of the factors obtained in step 1. Accordingly, we have found the factors of 60, which are 2 into 30 or 3 into 20 or 4 into 15 or 5 into 12 or 6 into 10. In next step, we have to express the coefficients of middle term, which is minus 7, as a sum or difference of the factors obtained in step 1. Here we have found the factors of 60 and we know that the difference of 5 and 12 is minus 7, 12 minus 5 is 7, 5 minus 12 is minus 7. So we will consider this factor 5 into 12. Now we have to separate the middle term in two parts, like x square will remain as it is. I am going to express minus 7x as minus 12x plus 5x, whereas minus 60 will remain as it is, equals to 0. Now we have to factorize the quadratic equation obtained at this step. For this, from these two terms I am going to take x common, so that inside the bracket we left with x minus 12. And from these two terms we can take plus 5 common, so that inside the bracket again we left with x minus 12 equals to 0 as it is. In next step we have one this term and one this term. We have two expressions, one expression is this and other expression is this, and from these two expressions we can take x minus 12 common, and in bracket we left with x plus 5 equals to 0 as it is. So we have expressed given quadratic polynomial of left hand side as the product of two linear polynomials. That is how the factorization is over. Since product of these two linear expressions or linear polynomials is 0, it means one of them has to be 0. So we write either x minus 12 equals to 0 or x plus 5 equals to 0. When x minus 12 equals to 0, then the value of x will become 12, and when x plus 5 equals to 0, the value of x will become minus 5. So from this we get x equals to 12 or minus 5. So these are the roots of given quadratic equation, or we may say solution of given quadratic equation. Now let us take one more example, and the given quadratic equation is x square minus 27x plus 182 equals to 0, and we have to find solution of this equation by using factorization. So we will follow the same steps as we did in previous question. So first step we have to do middle term substitution of the polynomial which is given on left hand side. So we get x square minus 13x minus 14x plus 182 equals to 0. Because minus 13x minus 14x will become minus 27x, and product of minus 13x and minus 14x is plus 182x square, which is equals to the product of these two extreme terms. Well students, while doing middle term substitution you have to mind that we have to separate middle term in such a way that the product of these two middle terms should be equals to the product of these two extreme terms, and when we add these two middle terms, that should be equals to the this term which is given in the initial polynomial. Next we have to factorize from these two terms x square and minus 13x. I am going to take x common, and inside the bracket we left with x minus 13. And from minus 14x and plus 182 we can take minus 14 common, and again inside the bracket we left with x minus 13 equals to 0 as it is. Now from these two expressions we can take x minus 13 common, and inside the bracket we left with x minus 14 equals to 0 as it is. Since product of these two linear polynomials is 0, so again either x minus 13 equals to 0 or x minus 14 equals to 0. So we get x equals to 13 or x equals to 14. So required solution is 13 or 14. So that is our answer. So this is how we can find solution of given quadratic equation by using factorization method. In coming videos, we will discuss about completing the square method and quadratic formula to find solution of quadratic equation. Thank you.